Hello and welcome. In this segment I want to talk to you about a diagram called an occurrence diagram, and it's worth noting at the outset that this is not the sort of diagram that's actually used in database design practice, but it's very useful in testing your understanding of the notions, particularly of cardinality constraints and to a lesser extent participation constraints. And so it's useful for students in learning and also for instructors in testing your understanding of underlying concepts. So for those reasons alone, we should go through this. Okay, so as a quick review, we have up top here a entity relationship diagram, binary relationship, customer owns an account. Okay, so in establishing our cardinality, we say for a given instance of a customer, that customer can own at most either one account or many accounts. Now, in most instances, we would say that a given instance of a customer can own multiple accounts. You could have a money market account, you could have a checking account, you could have a savings account, a CD, and so forth. So this is pretty clearly a many cardinality constraint. Let's try right to left. A given account can be owned by multiple customers or at most one customer. Let's start, for the sake of argument, with one. So we have a one-to-many cardinality relationship here. Okay, let's talk about how that translates to the occurrence diagram, which is these two ovals underneath their respective entities. So if we're saying that a given instance of a customer can own multiple accounts, what we're saying in effect is this is possible. Customer 1 owns account A10 and account A12, and what the heck, let's make them really well-to-do, and account 13. If this is many, then this would be okay. Okay, so that's what we see with an occurrence diagram. On the other hand, if this were 1, which would be a weird cardinality, but if it were, we could have this situation, this situation, this situation, this situation. This is fine. What we could never have is something like this, where customer 2 has both account A10 and account A13. That is a no-no, because we are saying that the cardinality is such that a given customer can own at most one account, means that this one or the other of these have to go, so that would not make sense, and we'd have to get rid of one of these bad boys. Okay, now if we have many to many, that's relatively straightforward. We can have this arrangement. We can also have this arrangement. So we can have, as an example right here, account A10 is possessed by both customer 5 and by customer 1. So if we were prepared to accommodate that here, the fact that there are multiple points of departure from A11 to various customers would be just fine. Okay, so that's the basics there. Let's run through one additional example with a word on participation. Okay, let's stick with our one-to-many, because I think that's a pretty sensible example. Given customer can own multiple accounts, we'll have C1 owning A10, A11, and for clarity's sake A12. So there's an example of that. But let's talk about participation as a review. Is it possible in the instance of an account for that account to not participate in the being owned by a customer? Can we have an account that's not owned by somebody? Let's say, for the sake of argument, that that is contrary to common sense and does not work in our problem domain, and thus this line is doubled and participation is mandatory, full. And let's talk about customer. A customer owns an account. Is it possible for there to be a customer that does not participate in the owns account relationship? Well, this is kind of a business decision. Depends how you define customer. if we were saying that customer, the only way you become our customer is if you have an account, otherwise we don't much care about you, or at least we don't call you a customer, we call you a potential customer, then this participation would be maximum. Both these lines would be doubled, and what it would mean is, okay, you can't have a customer that doesn't participate in the relationship, and you can't have an account that doesn't participate in the relationship. It means every one of these dots needs to be connected to at least one of these dots, and every one of these dots has to be connected to one and only one of these, every one of these needs to be connected to one and only one of these. These, as we mentioned right here, can be connected to multiple accounts because a customer can own multiple accounts. So basically what we're saying is if we wound up with this sort of arrangement, C4 doing A13 and 14, C5 doing A15, these two situations where we have two customers that don't participate in the relationship, these violate this mandatory or full participation, and these would not fly. They would have to be connected to something or other. I hope that's clear. And then, same deal here. And so if we had customer is anyone who is an actual account owner or a potential account owner, and this is a single line to denote optional participation or partial participation, then an arrangement like this is just fine. These are customers because they are someone or someone's whom we hope to serve in the future. They have a perfectly legitimate place in the database, and it's okay that they do not yet have a relationship with the owns account. We will tough it out and get them there with our superlative customer service and free toaster or whatever it is that as a bank we might do. So there is an example of the occurrence diagram and how we can use it to represent our understanding of both cardinality and participation. That's all for now. Thanks for listening. Study hard, and we'll see you soon. Well, we'll see you at exam time. That's coming up in just week 4. So don't lose sight of that. And if you're listening to this, then you're doing the right thing relative to your midterm exam. So long.